If you wanted to design the fastest, most efficient ship in the world, you'd make the front as sharp as a knife, right? You'd want it to slice through the waves. So why do the world's most expensive cargo ships have a giant, blunt, awkward lump stuck to the front? It looks like an aerodynamic disaster. It looks like it should be dragging the ship back. But this mistake is actually the only reason these giants can cross the ocean at all. Let's figure out this mystery right here on UnLogic. At first glance, ship design seems obvious. If you want to move through water, you make the front sharp, clean pointed, cutting forward. So adding a big rounded lump at the front, that feels wrong, like it should slow the ship down, like it should create more resistance, but it doesn't. It does the opposite. And to understand why, you have to see something most people never notice. Every time a ship moves forward, it creates a problem in front of itself. Not visible at first, but it's always there. Waves, as the ship pushes through water, it forces water out of the way. That creates a rising wave at the front, called a bow wave. And this wave isn't just water moving around. It's energy being lost. Energy that came from fuel. Energy that could have pushed the ship forward, but instead is being wasted pushing water up and away. So the faster and larger the ship, the bigger this problem becomes. Now here's where things get strange. Instead of trying to eliminate that wave directly, engineers decided to create another one, right in front of it. That bulge under the ship, called a bulbous bow, is carefully shaped to generate its own wave. And these two waves interact. When designed correctly, the wave from the bulb and the wave from the ship partially cancel each other out. This is called wave interference, more specifically, destructive interference. Instead of one large wave wasting energy, you get two waves interfering, reducing the total height. Less wave equals less energy lost, and suddenly, the ship moves more efficiently. This is the real reason that strange shape exists, not to push water away, but to manipulate how water behaves. And the impact of this is massive, because when a ship wastes less energy fighting water, it needs less power to maintain speed. Less power means less fuel, and for ships that cross entire oceans, carrying thousands of tons of cargo, even a small improvement becomes huge. We're talking about fuel savings of around 10 to 15%. That's not just efficiency, that's millions of dollars saved every year for a single ship. But here's the part most people don't realize. This only works under very specific conditions. The bulbous bow isn't a universal upgrade. It's not something you can just add to any boat and expect magic. It depends heavily on the size of the ship, the speed it travels, and how the hull is designed. If these don't match, the bulb can actually make things worse. And this leads to an obvious question. If it saves so much fuel, why don't all boats have it? Why not small boats? Why not yachts? Why not speedboats? Because at smaller scales, the physics changes. Small boats don't create the same kind of large, energy-wasting bow waves. Their speeds are different. Their interaction with water is different. And most importantly, they often operate at varying speeds. The bulbous bow is designed for a specific speed range. If a ship moves too slow, the waves don't align properly. If it moves too fast, the timing is off again. And instead of canceling waves, you end up increasing resistance. For large cargo ships, this isn't a problem. They move at relatively steady speeds, over long distances in consistent conditions. Perfect environment for the bulb to work. But small boats, they accelerate, they slow down, they turn frequently. They operate in conditions where that precise wave interaction just doesn't hold. So instead of helping, the bulb becomes useless or even harmful. There's also another factor. At smaller sizes, friction with water becomes more important than wave-making resistance. And the bulb doesn't help much with friction. So the benefit just isn't worth it. That's why you'll rarely see bulbous bows on small fishing boats, speed boats, personal yachts, but on massive cargo ships, they're almost everywhere. And there's one more subtle benefit. Because the bulb reduces the intensity of waves at the front, it can also make the ship's motion smoother. Less pitching, less up and down movement, which matters a lot for stability, especially in rough seas. But even with all these benefits, the most important idea is this. Ships aren't just moving through water, they're constantly interacting with it, fighting it, disturbing it, and sometimes the best way to move forward isn't to fight that disturbance directly, but to cancel it. That strange bulge at the front of a ship isn't there to cut through water, it's there to fix a problem the ship is already creating. And once you see it, you can't unsee it. This is UnLogic.